Hello everybody, this is Dr. Thunder. Today, I would like to show you how to use integral method to calculate the volume of ellipsoid. Here is the ellipsoid. We have the x, y, z coordinates, and then a, b, c are the length of the semi-axis. So a is from here, 0 to here, b is from 0 to here, c is from 0 to here. And we already know, if you Google it, the volume of an ellipsoid is V is 4 over 3 pi ABC. It's very easy to memorize. But today I would like to use the integral method to get the same answer. So let's write the equation for the ellipsoid. X squared over a squared plus y squared over b squared plus z squared over c squared equal to 1. So if A is equal to B equal to C, then we have a sphere, ball. If A is equal to B but not equal to C, then ellipsoid become a spheroid. But today we will not use any special case. We assume A is not equal to B, not equal to C, just the general case. So in order to use the integral method, we have to cut the ellipsoid into a lot of thin slices. For example, one such slice looks like that, and is located at Z. So we need to know the volume of each thin slice and then add all of these thin slices together. Then we get the volume of the ellipsoid. This is the central idea of the integral. So in order to get the volume of this thin slide, we need to know the surface area of this slide, which is ellipsoid. So we replot the YZ, two-dimensional YZ surface here. So this is Y, Z. Then this thin slice is located at Z here. We need to calculate the length of this line, which is Y. Or we draw it here, this is Y. We know that this is ellipse. So the equation describe this ellipse is y squared over b squared plus c squared over c squared is equal to 1. So we move this term here. So y is equal to 1 minus g squared over c squared, take square root, and then move b here. Again, we also need to know the other axis of this slice, which is x here. So we replot the two-dimensional xz plane here. So here is the x-axis, here is a z-axis, and then the location of the slide is about here. So we need to know the length of this line, which is x, and we also plot x here from here to here. So again, this is an ellipse. So the equation that describes it is x squared over a squared plus z squared over c squared equal to 1. So it's easy to get that x is equal to 1 minus z squared over c squared, take square root, move a here. So in the previous tutorial, we know that the area of an ellipse is pi AB, and A and B are the two axes of the ellipse. So the area of this slice, which is ellipse, become pi yx. so it's become pi yx. Then we plug y and x here, it becomes pi ba. These two terms are the same, so it becomes 1 minus z squared over c squared. And then to get the volume of these things like we need to know the thickness. Here the thickness is so thin, we set the thickness as dz. So the volume of slice is the surface area. We rewrite it here, multiplied by the thickness, which is dz. So as we mentioned before, we have a lot of thin slices. And then if we add these thin slices up, the volume of all of these thin slices will be the volume of the ellipsoid. But we only integrate half of the ellipsoid here. So here is the volume of the ellipsoid. So we need to add 2 because we only integrate half of the ellipsoid. So 2, and we add the integration sign here. We write this part here, pi ba, 1 minus z squared c squared dz. We integrate from 0 to c, from 0 to c here. So if we Google it, it's easy to find out that dz is equal to z plus c1. c1 is a constant. And then z squared dz is 1/3 z cubic plus c2. c2 is another constant. So we plug these two equations here, and then we move this constant out. So it becomes 2 pi ba c 1 minus z squared c squared dz. So it's 2 pi ba. First term is z. Second term is 1/3 z cubic and then c squared here. Here's a 1. And then plus constant. We use a c0 to represent c1 and c2. And then we add c and 0 here. First we plug c into z. Second we plug 0 into z. So now we plug c into z. So it becomes 2 pi ba c minus c cubic 3c squared plus z0. Then minus the other term, where 0 is plugged into z. So when 0 plugged into z is 0. When 0 plugged into z cubic is also 0. So there's only one term survive. So it's 2 pi ba z0. So these two terms eliminate each other. And then we summarize the whole thing here. So it becomes 2 pi ba. This 2 c squared eliminates c squared here. So it becomes 1/3 of c. So it becomes 2/3 of c. So eventually the answer is 4/3 pi bac, but we write it in the right sequence abc. So this is the same as the volume of the ellipsoid that has already been given in a book or in Google. So thank you for viewing. If you like my tutorial, please comment, like, and subscribe. Thank you.